Hi everyone, welcome back. This is tutorial 7, but today will be a little bit different. Today we're talking about our report 1, so there's no tutorial sheet and we're not solving any exercise pre-made. But I thought I still want to share this video to try to point out some things to think about, and also as a quick short recap of what we've done so far. Okay? So let's start with a little bit of admin. First, in quiz 2, you might have seen an announcement that question 4 was missing a little bit of information. So Eric will give the mark for everybody. But now that you have the complete one, you can try to solve. You might find what is the right answer. Yeah, so feel free. This is just a little warning. So report 1 is available, and you will find it. You can go to assessment research report. So please download the CSV with all the data we have. It's 4 time series plus the time itself showing when things happened, and then you have a description here in the PDF. Before I jump to the PDF, I would like just to recap quickly what we've done so far. Let's go. So we started talking about univariate time series. So what was univariate time series? From the name, you say just one variable, univariate, right? And they looked a little bit like that. We had the dependent variable y equals to some kind of constant, plus if it's an AMA 1, we have one leg here, and then we have the error, and I have one leg of the error there, right? And one thing is, you don't see any x's here. We only have y's. So we only talk about one variable. I want it to be really clear, because sometimes it might be difficult to draw a line in between when we're talking univariate and when we're talking multivariate. So let's go. Until week 3, what were we doing? We're trying to find nice models, nice equations to feed our data. And in the end, we're using the best model possible to forecast. So first, we estimated a set of arimas, right? So we had P's for legs of autoregression, as you can see here. We have Q's for legs of MAs, as we have here in green. And we also were dealing with some I's for integration. So it was D equals to 0, equals to 1, sometimes even more than 1. That's what we did. So with a lot of set of models, we would select the best ones based on AIC or BIC. And this was a tricky part that you might use your judgment depending on the results you get. Sometimes you will have a lot of intersection, pretty easy in your top 10, but sometimes you don't. So you will have to justify one way or the other why you're selecting the models that you're selecting. In this course, it's important to reinforce there's no one right answer. We have some data being generated by real life processes. For example, as you will see, GDP, inflation, and we are the ones trying to fit an artificial equation to it. So we're just trying to see which equation fits better, right? So use your judgment to select well your models, right? After you found the best ones, what you want, we're checking for white noise residuals through the Young box test. This test is a test for the null hypothesis, or H0, is that the residuals are white noise. So think, do we want it to be white noise or not? So it's stationary. We want the residuals here to be white noise. So we don't want to reject the H0 from our models. So given that, if we reject the H0, so we discard these models from our adequate set. So you probably remove it from your set. Or depending, if you have to remove everything, try a different set, like longer legs. I don't know. You use your criteria. And after you have this adequate set, you are able to run forecasts. And that's what we did until week 3, right? After this, you run forecasts. We have the code. You probably need to adjust your code a little bit, but for each of these items. But yeah, my recommendation for the whole assignment, start from what we have already from tutorials, and then you make adjustments. Or, of course, if you want to go and try to develop your own thing from scratch, no, it's all right, and it's good. You probably learn a lot. But also, if it's very different from the tutorial, it will probably take longer for us to also interpret and give you help, in case you need help. But still, if you want, I think it's worth it. All right, so up until week 3, we're talking about univariate process and this kind of equation here, right? Then week 4, we introduced multivariate time series. In this multivariate time series, they look a little bit like that. Look, there is a dependent variable, and there is also an independent one, exogenous variable there. And so we have the y, we have the x, and we also have the error. So far, in our ARDL models, we weren't doing also it could have more errors too, but usually in our tutorial, I don't think we were doing moving average lags. For it would be a different model. So autoregressive, it's what comes from this yt minus 1, at least like one leg of y, and DL, distributed lags, so lags from the other variables other than our dependent one, right? So what were we looking for when we were looking at this multivariate time series? We were looking for these dynamic relationships in week 4. So we had the ARDL model that looks pretty much like our ARMA, but we have some X's. And we also had our error correction model, which, if you remember, is just a reorganization of this one to make it look it kind of, if you watch the lectures, this current one for this week, we touched on it again. So the ECM looks more like a regression as we used to have in 2300. And the first things are the long run multipliers, the first coefficients. And then the last ones are the short run multipliers. With yeah, and that's what we were looking. So to analyze these dynamic relationships, we were generating impulse response functions, and the process is a little bit similar to what we were doing before here, but I wanted you to pay attention to the differences when we're dealing with one variable and when we're dealing with many variables. So we would estimate a set of ARDLs in this case. So we're not to do this impulse response functions, we were looking at autoregressive distributed legs, right? So there are functions that you can upload using it. Then we select the best models based in AIC and BIC, a little bit similar to what we did before. Then we check for autocorrelations in residuals. So have a look at the tutorial how we did that. After that, discard the models with a high correlation in the residuals. So probably you will notice a slight difference from what we did there and what we did here. Okay. And finally, run the IRFs for models left and analyze the dynamic relationship. So you analyze you will run your impulse response functions, and you can also have a look at the multipliers if you do the ACM and the little multiplier, the other equations we have that are more related to our ACM model. So this was week 4. Then week 5, we were talking about our augmented Dick-Fuller test. But it's important to, I thought it was, we were coming back when you're testing for the presence of a unit root, you once again just looking at variable per variable. All right, we're just getting one variable and making this test. So estimate a set of ADF models. So remember, in this case, this Dick-Fuller models, we don't consider errors, moving averages, I mean, legs on the moving average, legs on in the error. And what else I want to say? We do all data in levels, separated for all data in differences, separated if necessary, all data in a second difference, if that's the case. So in here, also, we're not mixing these D values. So comparing to ARIMA, when you're testing for the presence of unit root, you're just worrying about our P, about our autoregressive. And we're also testing if there is a constant, or what we call the presence of drift and the presence of trend. And remember, there are 3 combinations only. There could be drift. Oh, sorry, there could be no drift, no trend, drift, no trend, and drift and trend. Never no drift and trend, okay? So this, having trend without constant, it's something that we don't consider. After that, once again, AIC, BIC, so we can select the best models. Same thing here. Check for white noise residuals with Young box test. Same thing here. Discard models and that reject the H0. Same thing. So univariate, you can see they're relatively similar. Then we run the ADF test for the models left. In that case, now our interpretation, I like to call the attention that while here for the Young box test, we want the null hypothesis. We're stationarity or white noise residuals means we don't reject the null hypothesis. On the ADF, we kind of trying to reject the null hypothesis, so that we find that the data is stationary, or like there's no unit root, right? So in the ADF test, if for all the best models we had, if we reject the null the presence of a unit root for all of them, then you can probably say this is probably an I0 or integrated process 0, or like not integrated. There's no unit root, or it is empirically distinguishable from an integrated model. But if there's some uncertainty here, like I reject for a few models, but not for others, or I didn't reject for any of the models, then we need to consider the data not in levels anymore, but the difference data. So otherwise, that's why I put it here. Otherwise, repeat the test for difference data, possibly. So you go through all of it again. If when it's difference, you reject for all models, then you say, okay, I didn't reject at levels, but I reject everything when it's difference. So the difference data is empirically distinguishable from an integrated process, but you're still not 100% sure about the data in levels without differencing, right? So there's a chance it has a unit root there, but there's a chance it doesn't still. We're never 100% sure. So consider those cases. If you're sure it's I0, probably you don't need to consider models that are integrated, because without any integration or without taking difference, they are already a stationary process because they don't have a unit root, right? A little bit repeated and going around the same thing again and again, but as usual, I try to say many times so that it makes sense. All right. So this is what we did in week 5, and we were looking each time series by itself, each variable. Then on week 6, we had co-integration, and I'll move this co-integration here inside of the multivariate time series, because finally we're comparing to one with the other one. But to try to find co-integration, we will be testing one by one. You still need this information. And as you might remember, co-integration is something that happens between two I1 processes. It could be higher in different topics, but here in our course and usually in economics, it's still I1 process, okay? So if the difference or the residual, some type of combination of these two results in an I0 process, then they are these two integrated data. These two I1 are co-integrated, okay? So if you're just taking a difference of the two, you could go straight with our usual augmented Dick-Fuller test. But if you're doing a regression of one of our data on another one, or if you're doing a regression on a few of them, then you will remember last week that we were talking, there's a little bit more uncertainty because we're assuming that that relationship, like a coefficient and a constant for our regression. And in that case, we need to do an angle Granger test, okay? And then after we have the results from the angle Granger test, you will see if we reject the null hypothesis of the presence of a unit root, or if we don't, the same as we did with the ADFs. And finally, given the result, we might interpret the outcome and infer about co-integration, which we did last week. And you will see, if you need to go back to it, you can go back to the recording. There's quite an extensive interpretation. And also in tutorial 6, we have the whole interpretation in text. If you want to go through it a few times, you will notice in the recordings that I draw a little bit. I felt like if I draw what was going on, it kind of explains. So I hope it helps. But that's it. That's a quick recap of what we've done so far. So now let's move to the report. So report 1, there are a few things I wanted to call your attention. So we have a due date on the 28th of April, pretty important. It's worth 35% of your grade, I would say, also quite important, right? You have the option of using something that is not R, for example, eViews, Stata, Python. If you're more comfortable with it, MATLAB maybe, feel free to do so. It probably means you might have to implement a few things because what we shared was in R. And it also puts a little bit of a risk that maybe your tutors and the course coordinator won't be super a specialist in that specific programming language. So the support we can give you might be a little bit more limited if you use another one. But so going on, you're going to upload your report to turn it in. But it has to be in PDF and then single-spaced and 12 font size. Also, just one PDF. Please don't send multiple. Like, I don't even know why you would do. Oh, there are 2 questions, but please, just one. One very nice thing, you are allowed to work on this assignment with others. So at least discussing with others, trying to like share a little bit of your mind on where you are, but you're not allowed. We have Turnitin. You know, Turnitin can find the differences. Sorry, not differences, the similarities between reports. And well, it's kind of, if you never marked Turnitin, also put the reports one after the other when they're very similar. So it's pretty easy for us to identify if the text is repeated or it's very similar. It's not a big challenge. Turnitin does a lot of our job. It just puts them together. So be very careful, like discuss with other people, but still do your own analysis, write down your own test. As you know, there's no one right way of solving it. So it wouldn't make sense that your results and your interpretation is exactly the same as your friend. So yeah, try to make it make sense and explain everything in your own words. It's very important. So they had it is in red here. What else did I want to call your attention? The marking system with check similarities, blah, blah, blah. I've said it. And very important, and it's a mistake that happens a lot. It's when you're doing your R and your report, we don't want you to copy things from the console or take print screens and put it in the report. In here, it's saying output, and I got some students asking me, but how about the plots? The plots, we do want to see the plots. Maybe your check residuals, we want to see it. If it's an ACF test and you found something interesting, we want to see it, ACF or PACF. So what we don't want is, for example, you run the Young box test and then you copy the whole console and plug there. Look, we don't need to see the whole thing. You can just get the p-value, for example, and put it in a table, for example, right? What else? We don't want to see your whole matrix of sets that you calculated, like from top to bottom. Just give us the ones that you're moving forward until the end. Or maybe you will see the question one is a forecast. The forecast, as long as you put the title, we know which models they are because it's there in the title. But yeah, while you're doing, for example, your Young box test, please justify, if you're rejecting someone, justify why and what is the p-value. Maybe make sure you describe what's going on. More important than your results is your explanation of why you made the decisions you made. This is what is important for us, because the code, also the code, I don't think I mentioned, don't put the code, nothing, like no R code. And particularly, like, you're developing a little bit of code, maybe, but a lot of things is being shared with you. So we don't want reports to be exactly the same, right? Like, it's mostly Eric's code going on. So this is not important. The important thing is how you justify things. Okay, so I thought it was important to call the attention to this thing, because it's different. What we did in 2300, we wanted to see the code and we wanted to see the output, at least part of the output. But in our case, no. Maybe just the plots, perhaps some important information, summarize it into a table. No, don't copy and paste from the console. All right, that was it up to now. And now we can go to the questions. You will see there is question 1 and there is question 2. At this point, unless someone has a question to ask, I'm not getting a lot in detail into it. You will see that each are worth 50 marks. And you will see there's a lot of like motivation and practical purpose. Well, I don't think I will go too much in detail. Forecast model identification, forecast computation. Well, first, let me look for the minimum things, right? You will see the period goes from 1990 to Q3 until 2021 Q4. These are macroeconomic indicators for Australia. So you see there's real GDP, unemployment rate, CPI, inflation, consumer price index, right? And our cash rate. So question 1 is asking for motivation and practical purpose for what is described here. We will forecast model identification, forecast computation. So first choosing the model, then doing the forecast itself, and predictions and interpretation, and writing and organization. You can see some marks. There's a lot of marks for the writing and the explanation, right? Second part, you will see part A, are there any identifiable equilibrium relationships between CPI inflation and unemployment rate? B, if unemployment rate increases by 1% and remains at the same level thereafter, what is the expected effect, all else constant, on CPI inflation at the time of impact, 1 year after impact, 10 years after impact? And C, if cash rate increases by 1% and remains at the new level thereafter, what is same thing as before, expected level, all else constant, on CPI inflation at the time of impact, 1 year after impact, 10 years after impact? And then the marking is relatively similar. Motivation, practical purpose, model identification, estimation and testing, interpretation, writing, and organization. So interpretation, writing, and organization, there's no R code for it. Motivation, practical purpose, no R code for it. So you will see that a lot of your marks are not coming from the coding. Same here. 60% of your marks are not coming from coding, but from explaining. Okay. And that's what I wanted to share. Right now, I will open if someone has any question about all of this, about the report in general. And after that, I will stop the recording and allow people to ask questions if they prefer to be offline. Any question that you would be comfortable being recorded? Maybe a thumbs up in case you're typing or something. Otherwise, I might stop the recording where we are. Fantastic. All right, I will stop the recording at the moment. And so good luck with report. Enjoy your holiday. And if you guys need help, please join consultations. We will be allowed to help you with some software issues that you might have. So jumping into our studio, you explain to me what you want to do, and then I tell you how to do it. But probably we won't be able to explain you what you need to do for that specific question, all right? But we're still allowed to give you more help than we are allowed to give with the quizzes. Good luck, everybody. Enjoy your holiday, and I'll see you later.